Here we go. Today's lesson, students will convert between standard and vertex form of a parabola. They will also identify the characteristics of a parabola from each form. They will then use the graphs of parabolas to solve quadratic inequalities and word problems. A lot of different topics there. It's not going to take us a real long time, but several different topics we have to cover. Quadratics and parabolas. Anytime you're dealing with an x squared type equation, you graph it, you get what's called a parabola. We've dealt with that in previous lessons. There are two different forms of a quadratic equation. We've dealt mostly with standard form, y equals ax squared plus bx plus c. We have this other form called vertex form that we're going to start dealing with more here. Y equals a parentheses x minus h squared plus k. A lot of times you're going to see vertex form called transformation form. The reason why is when something's written in transformation form, it looks, go back to the section where we talked about transformations, you can see what's happening there. You can see is it being moved right or left. You can see is it being moved up and down. Like with the second equation, you see, and these are identical parabolas. You see one that's written in standard form, y equals 2x squared minus 12x plus 19. And then I took, and this is what you're about to start doing, I took this standard form and I wrote the exact same parabola in transformation form down here. And as a reminder from transformations, your parent function here, y equals x squared. Take away all the 3's, the 1's, 2's, take away all that stuff. Your parent function is y equals x squared. Now let's talk about the transformation. Let's review real quick. Minus 3. Where does that move your parabola? Right through. Plus 1 tacked onto the end. What does that do to your parabola? And you see the vertex used to be at 0, 0. That's been moved right through. It's been moved up 1. What's that 2 going to do? It's a vertical stretch twice as tall. Good. So what used to be here, let's just talk about vertical stretches. We took our parabola, moved it right 3 and up 1. So what used to be at 0, 0, 1, 1, 2, 4, and 3, 9 is now, what used to be there is now here. Okay, at this point that used to be right here is now, let me change colors. What used to be right here is now here. What used to be here is now here. That one stayed the same. What used to be down here at 1, 1 is now at kind of 1, 2. What used to be at 2, 4, or excuse me. Yeah, what used to be at 2, 4 is now at 2, 8 is twice as tall. Okay, just going over and reviewing transformations. Now here's how you do it. Rewrite each function in transformation form. And I'm going to call that probably transformation form more than I do vertex form. Rewrite the function in transformation form. Here's how you do it. Gonna love it. Complete square. Again, I told you completing the square was by far the most pointless way of solving a quadratic equation. But we need to know how to complete the square to do stuff like this. When we dealt with circles, we had to know how to complete the square to get it from like a standard form to a transformation type form. Same way here. I'm going to rewrite f of x. I'm going to put a y in there just so it's easier to write. Y equals x squared plus 6x. I need to complete that square. Autumn, what can I add to both sides? Do you remember completing the square? What can I add here to complete the square? X squared plus 6x plus 9. The way you complete the square, take whatever term's in the middle. Take whatever your middle number is, half it, and multiply it by itself. Half of 6 is 3. 3 times 3 is 9. Whatever you add to one side, you have to add to both sides. So I now have y plus 9 equals, factoring the right side. Might as well factor that for me. X plus 3 times x plus 3 or x plus 3 squared. Reminder, after you complete the square, it'll always factor into x plus whatever half of that middle term was. In this case, x plus 3 squared. Last step, move your 9 back over, and I'm going to change my y back into f of x. F of x equals x plus 3 squared minus 9. That's now transformation form. I don't think, we're not asked to do it on this problem yet, but think about the parent function. Think about the parabola 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. What's the vertex? Drake, where's the vertex of that parabola? 0, 0. Right here. That vertex has been moved. It's been moved, help me out, Mary. It's been moved where? Careful, up or not right, but it's backwards in here. Left 3 and good. So your parabola's been moved left 3 and down 9. Do you see why they call it vertex form? There's your vertex. Negative 3, negative 9. If you move that vertex left 3 down 9, your new vertex is negative 3, negative 9. Moving on. Same thing, rewrite each function in the form, well, in transformation form. Here's what makes this one a little bit tough. If you've got a number out front, number in front of x squared, a little bit hard. First step, take your constant, move it to the other side. So again, I'm going to write this as y. Y minus 3, which we didn't have to do that on the last one. We didn't have a constant. But anytime you have a constant, move it to the other side. Just makes things a little bit easier. You could leave it there, but it's going to require a little bit more thought. So just move it to the other side. If there's a number in front of x squared, whatever the number is, factor it out. Even if this was a 3, factor it out. And we know we're going to have to think a little bit about what does 3 multiply by to give me 20, but we can do that. Well, we have 2 parentheses, x squared minus 10x. Leave you a space. Canada, half the middle term, which in this case is 10. Half it, multiply it times itself. So what do you get? 25. We're going to add 25 to, got to be careful, we added 25 to both sides. Because did I really add 25 to, I added 25 inside parentheses. But what did I add to the right side? Does anybody see that? 50. You did not add 25 to this right side. You added 2 times 25. So over here on the left side, we're going to add 50, which is 2 times 25. We now have y plus 47 equals 2 parentheses. Jackson, factor that for me. And if you want to save yourself a step, you can mark out your 47 and move back over. So f of x equals 2 parentheses x minus 5 squared minus 47. Transformation form. Okay. Hey, here we go, guys. Back to it. Parabola characteristics. Parabola characteristics. Here you see 2 different parabolas written in 2 different forms. You see transformation form on the left. You see standard form on the right. Every parabola is symmetrical. It has what's called an axis of symmetry. Now we're talking about just the pieces of a parabola. Every parabola has an axis of symmetry. In order to find an axis of symmetry, if something's in standard form, you might want to write these formulas down. The axis of symmetry can be found by the formula x equals negative b over 2a. And we all know what a, b, and c are. Think about your quadratic formula. A is the number in front of x squared, b is the number in front of x, c is the number being abstracted to the end. So the axis of symmetry, and you see here, the axis of symmetry is a vertical line. Vertical lines have equations in the form x equals a number. So your axis of symmetry can be found by that formula there. Note this. Go back now to transformation form. Your axis of symmetry passes through your vertex every time it will. So if you're dealing with transformation form, Anybody tell me where you find your axis of symmetry? Yeah, it's the x value of your vertex, right? So go to x, or just look for x value of vertex. And your actual formula, or your actual equation will be x equals that number. Like in this one, our vertex is at 3, 1. We find that from here and here. Since our vertex is 3, 1, our axis of symmetry is the line x equals 3. In transformation form, again, our basic formula is y equals a times x minus h squared plus k. Our vertex can be found right here, h, k. Because h tells us that our parabola's been moved either left or right, our k tells us our parabola's been moved up or down, so we can find our vertex by looking here and here. If we're in standard form, well, to find the x value of vertex, it's right there. Again, there's a connection between the axis of symmetry and your vertex. The axis of symmetry passes through your vertex, so whatever that x value is on your axis of symmetry will also be the x value on your vertex. To find the y value, you simply take and plug this x value into your equation. If you get x equals 3, plug in 3, that's going to give you your y value. If you get x equals 4, plug in 4 into your original equation, that's going to give you your y value. So find your x from your axis of symmetry, plug it back in, that's going to tell you your y value. And the last one, opening. Some parabolas open upwards, meaning that whole range. They cup up. Some parabolas cup downwards. To find out whether a parabola cups upwards or downwards, you simply look at your A. And in our transformation form, this was A. And notice in our standard form, the A is going to be the same number. That's the reason we call it A in both of them. If your A is positive, it's going to cup upwards. If your A is negative, because we know that's a transformation, it would flip it down. If your A is negative, it would cup downwards, and that's going to be the exact same thing for standard form. Next problem. It says for each parabola, determine whether the parabola opens upward or downward. Find the vertex, find the axis of symmetry, the range, find the maximum or minimum value of the function, and the intervals on which the function is increasing or decreasing. That's a lot, right? Let's do one at a time. First, determine whether the parabola opens upward or downwards. To determine whether it opens upward or downwards, simply look at the A up front. If it's a negative, it's going to open down. Next, find the vertex. Your basic parabola is y equals x squared. This one's been moved. Parker, tell me, how far has it been moved and in what direction?
It would go to the left 4 and down 8.
Left 4, down 8. That's your vertex. The axis of symmetry. Reminder that your axis of symmetry passes through the vertex. So here's kind of what you got. Negative 4, negative 8. Let's say it's somewhere down in here. It opens downwards. That's kind of your parabola right now. But Kayla, can you tell me what the axis of symmetry is? And again, the axis of symmetry splits it perfectly in half. Passes through the vertex. I'm going to call it the A of this. X equals. Passes through the vertex. Yep. Simply the x value of the vertex. X equals negative. Make sense? Find the range. And this goes back, and I think the big reason that this is on there is to review from last chapter. Domain, range. Which, by the way, your domain, you can plug in anything. This parabola continues left and right forever. That's the reason I didn't ask you for domain. The domain of any parabola that opens up or down is always going to be negative or positive infinity. You plug in anything. But what are we going to get? Josh, can you tell me what my range is? From negative infinity up to where? Anybody? Negative. Okay. Because your parabola continues down forever. It goes up to this vertex point. That's the maximum. That's the highest point on your parabola, and it's located at -4, -8. Okay, that's the highest your y value will ever get since it's cut downwards. The range. Find the maximum or minimum value. Right there's your max. Since the parabola cups downwards, you want to have a minimum. Again, since this parabola cups downwards, your maximum, you'll have a maximum value. If your parabola cups upwards, you won't have a maximum. Okay, it continues up forever, you would have a minimum. So in this case, your maximum value would be the highest, your minimum value would be the lowest y value. So the highest y value found right here is -8. And where is it increasing and decreasing? Your parabola increases, okay, starting at -infinity, and it increases all the way up to this point here. So it increases, and we're talking x values here, we're going left to right. We're increasing on the interval from -infinity up to, anybody want to tell me? -4. I don't include -4 because at that point we're neither increasing nor decreasing. And then we start decreasing, and we do decrease from -4 to positive. Now let's do the exact same thing with one that's in standard form. If you want to, this is entirely up to you. If you want to, you can take a parabola that's in standard form, and from what we did a while ago, you can rewrite that in vertex form and do it like we just did. What I suggest is learn, okay, what if it's in standard form, how do I do it then? What if it's in vertex form, how do I do it then? So here we go. Since it's in, again, standard form, let's find, first off, does it open upwards or downwards? This one opens up. So it looks like this. Will it have a minimum or a maximum? It'll have a minimum instead of a maximum. Let's see. Open up or down and open up. Find the vertex, and here's your process for vertex. You've got a formula, x equals -b over 2a. Garage, what's b?
-4.
So -4 would be 4, and what's a garage?
2.
So 2 times 2 is 4. That's the x value. Not only is that, you could go ahead and put, this is your axis of symmetry. X equals 1 is your axis of symmetry. So your vertex is going to be 1 something. To find the something, just plug it in. Because your vertex is on your parabola, right there. So if the x value of my vertex is 1, to find the y value, just plug that 1 in. You get 2 minus 4 minus 9. 2 minus 4 minus 9, I believe that's -11. Checking on that. We're good with that. And then from there on out, it's going to be very similar to the last one. The range, Austin, what are my y values?
From -11 to +10.
Yeah, from -11 up. So your range is from, including -11, it's on the graph, from -11 to infinity is your range. The maximum or minimum value, Seth, in this case we said we had a minimum value. What's your minimum? -11. It's your lowest y value. We can find it with our range. The intervals over which it's increasing or decreasing. This one decreases first. From left to right, we're going to decrease, and then we're going to hit our vertex, and we're going to start increasing. Autumn, tell me, where is it decreasing? Careful, x values. -infinity to 1, and then it starts increasing from 1 to +2. Okay, the next part of the parabola is the intercepts. We've already talked about this. The x-intercepts, the y-intercepts, we discussed this when we talked about lines. We've already discussed it with quadratic equations. Reminder, at an x-intercept, you got a graph. Add an x-intercept, what's true about y? It's equal to 0. Remember that for the rest of the year. Same thing vice versa, y-intercept. Add a y-intercept, x is 0. So in this section on finding intercepts, you're going to practice plugging in 0 for x, plugging in 0 for y. That's all you're doing. You're looking for where does my parabola cross the x-axis, where does my parabola cross the y-axis. To find the y-intercept, we'll do that first. Find the y-intercept, we plug in 0 for x. So my equation turns into, notice it turns into y equals, that's what we want. We want a y-intercept. If you ever get confused by that, to find a y-intercept, if you plug in 0 for y, you don't have a y. So to find a y-intercept, eliminate the other variable. Y equals -2 times 0 plus 4, be 4 squared minus 8. Or y equals -40. You can check me on that. Will a standard parabola ever have 2 y-intercepts? No. Now, he was talking about a while ago, what about an x equals parabola? What about a parabola that's on the side? Yeah, it'll have 2. Because it's the inverse of a standard parabola. So a standard parabola normally has, notice I say normally, has 2 x-intercepts, where if you flip it on the side, it would have 2 y-intercepts. Again, to find the x-intercept, plug in 0 for y. So, I'm going to put the 0 at the end. 0 equals this stuff. So this stuff, -2 times x plus 4 squared minus 8 equals 0. Something odd about this. To solve this equation, don't do this. Whatever you do, don't square out x plus 4. You're making your life so much harder. Move 8 and move -2. To move 8, we're going to do plus 8. To move -2, we're going to divide by -2 because it'll be multiplied, right? What do you get on the right side? -1. Now we get rid of the square by square rooting. X plus 4 equals, don't forget to do what when you're square rooting? Plus or minus the square root of -4. I can really stop there. Can anybody tell me where my x-intercepts will be? Imaginary. You're not going to have any. Anytime you have imaginary x-intercepts, which I'll finish this out just to remind you on how to do imaginary stuff, you're not going to have imaginary x-intercepts. Okay? If your answer turns out to be imaginary, you have no x-intercepts. So what does that say about the parabola? Well, here I just sketched one. But my parabola doesn't cross the x-axis. It does cross the y-axis. Do you notice your a value was negative as well? And it crossed the y-axis down here like -40, and your parabola had a negative a value, so it cuts down. Do you understand why it doesn't have x-intercepts? If you would have thought about the a being negative and how low your y-intercept is, you really didn't even have to attempt this because you knew it wasn't going through. We finish it out. You can move -4 over there if you just want a refresher. Positive 4 becomes -4, plus and minus. The square root of -4 would be the square root of positive 4, which is 2, times the square root of -1, which is I. There's your imaginary roots. Another the same. Find the y-intercept and the x-intercepts. In this case, you have it in standard form. If you want to, you can write it in. I don't know why you would want to. But you could go through the process of completing the square, and you could write this in vertex form if you'd rather. But here we go. Find an x-intercept and find a y-intercept. And here, let's do this first. Y-intercepts are really easy. When something's in standard form, because you got to plug in 0 for x, look. This goes away, y equals -9. My question, is the number at the end always your y-intercept? Yes. Think about lines. Cover up the -2x. What if this was a line? What if it was y equals -4x minus 9? Is the number at the end always your y-intercept? Yes, that would be slope. Remember slope-intercept form? Why is the number at the end always your y-intercept? Because when you plug in 0 for x, what happens? That goes away too. There's your y-intercept. That's the reason why. No matter what kind of equation you have, if it's in the standard form, whether it be a cubic, quartic, third power, fourth power, fifth power, sixth power, the number at the end is always your y-intercept, no matter what kind of graph you have. Okay, x-intercepts, we're going to take out the y, we're going to put in 0. So we now have 2x squared minus 4x minus 9 equals 0. We needed this problem. This is going back a few weeks. Solving quadratic equations. You have two main methods of doing so. Well, actually three. If you want to use your graphing calculator and use your 0 function, that's pretty easy. Or we can try to factor it. If you don't want to factor it, you can use your quadratic formula. Let's try to factor it. If there's a number out front, what kind of factoring do we use? Bottoms up. Move the 2 to the end. We now have x squared minus 4x minus 18 equals 0. We ask ourselves what multiplies to give me negative 18, what adds to give me negative 4. Is there anything? No. What does that tell us? Can we factor? No. Will not factor, so we're going to have another method, and that method is the quadratic formula. Negative b plus and minus the square root of b squared minus 4ac all over 2a. Michael, what part do we do first? Good. And it's called the discriminant. B squared minus 4ac. B squared is 16 minus 4 times 2 times negative 9. Anybody got that? There you go. Negative 72. So minus 72, that makes that a plus 72. That verifies to me that that's not factored. Had that been a number like 16, I can find the square root of 16. Had it been 4, 9, 25, a number that we can find the square root of, yeah, we could have factored that, but it's not factored. So now that we found our discriminant, let's plug everything else in. Negative b is 4, plus and minus the square root of that stuff over 2 times a is 4. Clean it up. Square root of 88. Drake, do you know of any special or any perfect square roots in 88? Think about what you know the square root of. You know the square root of 4, 9, 16, 25, 36. It's a small one. 4. You can split the square root of 88 into the square root of 4 times the square root of 22. Everybody good with that? And 22 won't break down again because the only thing we know is square root of 2 times square root of 11. We don't know either one of those. So we now have 4 plus and minus 2 root 22 over 4. Let's go through and divide. We've got 3 terms there. Divide everything by 2. That gives me 2 plus and minus root 22 over 2. If you want to split it, you could write that as 2 over 2 would be 1 plus and minus root 22 over 2. Either one of those answers are fine. That's your x-intercept. I do want to point out while you're writing this down in your notes, I do want to point out your x-intercept, parabolas are symmetrical. If one of my x-intercepts is 1 plus root 22 over 2, and you could write that as a decimal if you wanted to. You could put root 22 divided by 2 in your calculator, get that as a decimal. But if one of your answers is 1 plus root 22 over 2, your other answer is 1 minus root 22 over 2, and it's symmetrical. Can you tell me what value is right in the middle of there? 1. So what is 1? X equals 1 would be your axis of symmetry. So once you do all this intercept work, you can look right here and find your axis of symmetry. Wow. Look at this formula. So you can look right here to find your axis of symmetry. What's the formula for the axis of symmetry? Negative b over 2a. It's the first part of your quadratic.